Hello. Today I'm going to be giving a tutorial on how to, how depth first search works. I already put in a tutorial of how breadth first search works, and now this is just depth first search, which is a little bit different from BFS. So people just call this DFS really, but basically it means depth first search. So I'm just going to clean this, and I'll get right into it. So let's say we pick our source as 1. So our source is 1 and we start from there. So for BFS uses a queue, which is first in, first out. But depth first search, DFS, uses a stack, which is the last thing that goes in, comes out. Sorry, the first thing that goes in comes out last. So just remember that. So this is for a queue and this is for a stack. And I'm just going to get right to it. So let's say we start from vertex 1 and we have a stack here, right? So we start from 1 and I'm just going to make, so let's just assume we have an array here of vertices. So we have 1, 2, 3, 4, and we have 5. So whenever we visit a vertex, I'm just going to mark it as visited. And just like breadth first search, when a vertex has been visited, we don't add it back into the stack. So let's start from 1. We place 1 into a vertex. We mark 1 as visited. And then we go right to the next one. So we can just go to 2. So this is, we go to 2, we place 2 into the stack. And we mark 2 as visited. And basically the idea here is when you are at a vertex, just go to the next adjacent vertex that has not been visited yet. So we go right to 2. 2 has not been visited, so we place it into the stack and we mark it as visited. And when we get to 2, we check vertices adjacent to 2. In this case, we have 3 and 4. Let's just go to 3. So we mark 3 as visited, we place it into the stack, and we check 3, and we check what vertices are adjacent to 3. Well, just like, like I said, now when we are at 3, we can say, okay, 2 is adjacent to 3, but 2 has been marked as visited here, so we don't place it into the stack again. So we want to keep placing a vertex that has not been visited yet. In this case, we have 4. So we go to 4, place 4 into the stack, mark 4 as visited. And the idea here is to run depth first search as long as our stack is not empty. So when we get to 4, as you can see, 4 is connected to 3, 2, and 5. Now we can check, well, 4 is connected to 3, but 3 has already been visited, so we don't add 3 back into the stack. It's connected to 2, but 2 has already been visited, we don't add 2 into the stack. 4 is connected to 5, but it has not been visited yet. So we add 5 into this stack, and we mark 5 as visited. Now, when we get to 5, well, you can just say, well, 5 is connected to 1, but 1 has been visited. It's connected to 4. 4 has been visited. So there's nothing else to this. So what do? We just pop in the stack. So now, well, we pop the stack. So now we have, we pop 5. And then we go to 4, right? Now we're at 4. I'm just going to do it here. So this was the first thing we popped, right? So we popped it here. Let's say pop 1, and this would be pop 2, right? So when we're at 4, well, we already checked 4, right? 4 is connected to 5, it's been visited already. 4 is connected to 2, it's been visited already. It's connected to 3, it's been visited already. So we pop 4 out, and then we go to the next one, which is 3. So we come to 3 here. Let's just say pop 3. And so this was 4, and this is 3. And when we get to 3, 3 is going to get to 4 and 2. They've both been visited. And then, we move to the next vertex. So we pop out 2 also. So let's just add 2 here. And same thing, 2 is connected to 1, 4, and 3. They've all been visited already. So we go to the next thing, which is 5. Which is 1. And when we get to 1, 1 is connected to 2 and 5, and they've been visited already. So we pop it out, and now our stack is empty. And once our stack is empty, we are done with depth first search. So this is all I have for today. I'm going to actually make another tutorial in which would maybe like give a much better explanation as to why we pop the stack. Well, thanks for watching. I hope you enjoyed this.